Hi guys, I'm going to do things a little bit differently for Unit 8 here. We're going to pre-record a few of the lessons. If you want to watch these ahead of time, you can. And then when you come into class, hopefully you have some questions that we can go through so we can spend more time working on things that you need help with instead of watching me do the problems. The unit we're doing is Unit 8, and these are all our trigonometric ratios. So there are 3 that we're going to deal with, tangent, sine, and cosine. And the thing that kind of makes trig ratios special is that they all deal with right angle triangles. So if we have a triangle with one corner that's 90 degrees in it, we can apply these ratios to them to solve problems, figure out angles, missing sides, all sorts of things. So we're just going to jump right into the tangent ratios, the first one, and then we'll talk a little bit about the other 2 later. The ideas are the same for all of the different ratios. We're just talking about different sides of our triangle. So general definition here of angle A, this little sign here means angle. So if angle A is an acute angle, meaning less than 90 degrees in a triangle, so here's angle A down here. We've labeled it as A. This corner is labeled as B, and this corner is labeled as C. So in this triangle, B is a 90-degree angle. We have angle C up here. I don't know what it is, but I'm not really interested in it right now. Everything we're dealing with is dealing with this angle A in the bottom corner. So we have some special names for our A's, or the sides, sorry. The side opposite angle A, so if I go straight across my triangle and I go to the opposite side, this is called the opposite side. So I will abbreviate that as OPP, or opposite. The side right next to angle A down here at the bottom is the adjacent, which I'll call ADJ. And then there's the longest side in a right angle triangle. You guys will probably remember this is called the hypotenuse, and I'll call it the hype. So these are the things, the 3 sides of a right angle triangle. You have the opposite side, which is all the way across. If I drove straight across, I'd run into the opposite side. I have the hypotenuse, which is kind of opposite the right angle and the longest side in your triangle, always. And then I have the adjacent, which is making up the angle I'm dealing with, in this case, angle A. So if I can take the length of a side of a triangle, the length of the opposite side, and I divide it by the length of the adjacent side, that's going to give me a ratio, and that ratio is going to be the same no matter how big my triangle is. So if I have a really tiny triangle like the one on your page, then we can look at the ratio between those sides and figure out lots of information about this triangle. Or I can take a giant triangle. If you think of, maybe you have a tree in your yard, and you want to measure how high the tree is, or you know how high the tree is, and you walk back so many meters and you know how tall the tree is, you can use the information. You can figure out the tree's height and then how far you are away from the tree, and then you can get the angle. So it can be a really big tree, or you can have a telephone pole or something like that. And if you know the ratio, like how big the side is or how big the thing is compared to how far you are away from it, you can figure out angles. And we can use these angles to do everything from like navigation and all sorts of other stuff. So kind of filling in the blanks here, the value of the tangent ratio is usually expressed as a decimal that compares the lengths of the sides. For example, if the tangent of A, we abbreviate it tan A, is 1.5. So that means that any similar triangle with the angle A, the length of the side opposite angle A is 1.5 times the length of the side adjacent to A. You can use your scientific calculator to determine the unknown angle, and to do this, we need to use the tangent button on your calculator, but in this case, we're going to use the tan -1, and that's called the inverse tangent. So that might not make a whole lot of sense right now, but we'll look at what that means in a couple examples. So we'll look at some basic examples here. All right, So we have a question here. It says, determine the tangent of x. So I have a triangle. I need to look at the triangle and figure out where x is. And then I'm going to label my sides from there. So here's x up at the top. I found x. It says tangent of x. So I found x. X represents an angle. And from that angle, I need to label my sides. Now the first side I'm going to always label is my hypotenuse, which is this side because it is opposite the 90-degree angle, or you can think about it as being the longest side. If I started at angle x, we were talking about a, but now we're dealing with x. If I go all the way across the triangle, and I drove across, I would end up at the opposite side. If I have the side that makes up part of my angle is the adjacent side. So those are the three sides I'm dealing with when I'm trying to find out x. And x in this case is an angle. So what is that angle? So I know the ratio of sides is going to give me that angle. So from the previous page, I know the tangent of x is the length of the opposite side divided by the length of the adjacent side. In this case, the opposite side has a length of 6, and the adjacent side has a length of 12. So if I was finding the tangent of x, it's equal to 1 over 2. So that's it. Tangent of angle x is 1 over 2. The next question here is asking me to find the tangent of angle z. So what I'm going to have to do is go back to my triangle, because now I'm looking at a different angle. My sides are going to have different names. So if I look at my triangle again, it's telling me to look at z. So okay, I'm going to look at z. So I'm going to erase this. Angle z is now down here. I'm not dealing with angle x up here anymore. I don't want to deal with that one. I'm dealing with z because it says z in the question. And I need to relabel my sides. Now the hypotenuse is not going to change. It's going to stay the same. And I still have my angle z here. If I go opposite my z, I'm going to end up here, which is opposite. And then down here, I have the adjacent. Those are the only three sides I'm dealing with. So the tangent of angle z is the opposite side, the length of it divided by the adjacent side. And in this case, the opposite side has a length of 12. The adjacent side has a length of 6. 12 divided by 6 is 2. So the tangent of z is equal to 2. So the idea here is that I'm dealing with the same triangle, but the triangle has three different angles. I have x, y, and z. I don't know x or z, but I know y is 90. So these are the things I know. Hypotenuse is not going to change. It's always going to be the same. It's always opposite the 90-degree angle. It's always the longest side in my triangle. So those are the ratio of the sides. I could have a really small triangle, or I could have a really big triangle, but the ratio of the sides is going to remain the same. The next one, C and D, asks us to actually calculate what that angle is. Now, we haven't done anything with angles, so I don't know what the angle is. There's nothing in my diagram that doesn't indicate anything other than a 90-degree angle. So what I can do is use trigonometry to figure it out. So remember this little, I guess this almost looks like a triangle. This means angle. The angle x. What is that going to be? So if I want to find an angle, I'm going to take the tangent, but I'm going to take the inverse tangent. So I put a -1 up to it. Remember that a negative exponent means flip it. In this case, angle x. Angle x was the one up here. So I'm going to relabel my triangle. This is the opposite. This is the adjacent. So the angle x is the inverse tangent of, in this case, opposite is 6 divided by 12. What does that equal? Now what we're going to do is I'm going to jump over to my calculator here. And your calculator is going to be different than mine. So it's important that you figure out how to use your calculator. So Some calculators you're going to push the tangent button, then the angle. On others, you'll push the angle, then the tangent. Just depends on what you're trying to find. So in this case, it's important that I actually find in the angle. So you'll see that my calculator has a tangent button right here. It says tangent, and it's just TAN. And that's the button I'm going to use. Now, above the tangent button, you can see that I have this tangent to the -1. So every time I'm trying to find an angle, I'm going to use that tangent to the -1. But to get to that, I have to use the second function tangent. So my calculator just works just like I press the buttons normally. So I go second function tangent. You see up into my window here, I get tangent of -1. And then I'm going to put a bracket in there. And the question was asking for 6 divided by 12. So you could put in 0.5, or you can go 6 divided by 12. And when I go 6 divided by 12, inverse tangent of that, 6 over 12. I can press equals, and it's going to give me an angle. In this case, 26.56. For the purposes of this question, we'll just call 26.56 27. It's 26.5, we're going to round it up. So right here, I'm just going to write 27 degrees. So that's saying if I have two sides of a triangle, the opposite side has a measure of 6, the adjacent side has a measure of 12, or if the ratio between those sides is 0.5. So if I have a side that's, 50 divided by a side that's 100. So the opposite side has a length of 50, the adjacent side has a length of 100. The angle that triangle makes is always going to have 27 degrees. Doesn't matter how big or how small, it's always going to be 27 degrees. So let's look at the next example. Angle Z we're trying to find now. And remember we had to relabel our triangle to figure this one out. So if we started at Z, now this is the opposite up here, this is the adjacent down here. We have 12 over 6. We want to figure what that is. Or we can call this the inverse tangent of 12 over 6, which is just 2. So what is that going to be? So if we look at our calculator again, we're going to use the inverse tangent. So I'm going to go second function, tangent. And I can go 12, I should put a bracket in there, 12 divided by 6, and hit equals, and I get 63.4. Or I can take this inverse tangent, second function tangent, and instead of 12 over 6, I'm just going to go 2, because 12 over 6 is 2. That gives me the same thing, 63.4. So back to the question, we'll call it 63 degrees. 63 degrees. The little degrees sign up here kind of looks like the 0th power, but it is degrees. So try not to get those things mixed up. It'll be obvious when you're dealing with angles, you won't be dealing with exponents of 0 power. All right. The next question here is kind of like a word problem. Same sort of idea. Support cable is anchored to the ground 5 meters from the base of a telephone pole. The cable is 19 meters long. It's attached near the top. What angle does the cable make with the ground? So let's draw a picture. Here is my telephone pole. And just nice little grass growing at the bottom. There's my pole. It says it's anchored to the ground 5 meters from the base. So here's the base. I'll go over here. This is 5 meters. So there's my anchor. And then the actual cable comes from the top of the pole, anchored to the ground here, and this is 19 meters long. So I know a bunch of information about this already. It's anchored to the ground, it's 5 meters away, the cable's 19 meters long. What angle? So I'm trying to figure out what this is down here. So I'm trying to find an angle, and I'm going to use, for all of my angles, I'm going to use this symbol. It's a Greek letter, it's called theta, and in math in general, it means angle. So I'm going to call this down here, angle theta. Okay, so we want to use the tangent ratio of our angle theta to figure out what it is. So tangent is going to be the length of the opposite side divided by the length of the adjacent side. Now you're thinking probably, if you're a step ahead of me, this is the hypotenuse here. If I go straight across, this gives me the opposite side, and then this one at the bottom is the adjacent side. I don't know what this opposite side is, but what I do know is this is a 90-degree angle down here, and I can use the Pythagorean theorem to figure out what the opposite side is. So what I'll do is I'll go a squared plus b squared is c squared. The a squared we'll call the opposite side, b squared we'll call the adjacent side, and then c squared is always the longest. In this case it'll be the hypotenuse. So we have all of these things squared. Plug in some numbers, see where we end up. The opposite, let's call it x. X squared plus the adjacent is 5 squared is 19 squared. All right, x squared, 5 squared, plus 5 squared is 25, and 19 squared is 361. Subtract 25 from both sides, I end up with x squared is 336, and then take the square root of both sides, and I end up with x is equal to 18.3. So x, or the opposite side, is 18.3. So I'm going to use my trig ratio here. The tangent of the angle I'm trying to find, the opposite side has a length of 18.3. The adjacent side was given in the question as 5. So to figure out the angle, theta, I'm going to take the inverse tangent of 18.3 divided by 5. So if I jump to my calculator, I'm going to go second tangent and 18.3 divided by 5. Close my bracket. It works out to 74 degrees. 0.7. So we'll call it 78. Or sorry, 75. Theta is 75 degrees. You, on your calculator, in order to make this work, you may have to take the 18.3 and divide it by 5. So if you have your calculator, you go 18.3 divided by 5, you get 3.66. So what you might have to do in order to make your calculator work, if you don't have the brackets like I do, you may have to go second tan 3.66. And then you still get the same angle, but it's just how you enter it into your calculator. So we can also use the tangent ratio to calculate the length of unknown legs of a triangle. We use indirect measurement to calculate the missing lengths instead of using direct measurement. So indirect measurements are useful when lengths we are trying to determine are very large. You can imagine if I had a really, really big tree in my yard and I wanted to know how tall it was, well, I'd have to rent a crane or a scissor lift or something and get up to the top, and then I'd get a big measuring tape, and it just wouldn't work. Or something like measure the height of the CN Tower. Well, I don't have a measure tape long enough, but if I can figure out how far I am away from the base, figure the angle to the top, that's enough information to figure out how tall something like that is. So it's kind of where this comes in handy. So as a general sort of rule for talking about triangles, we're going to use capital letters to represent the angles, and then we're going to use lowercase letters to represent the sides. If I have angle A up here in the top, if I go opposite side, I get lowercase a. Same thing goes with B. If I'm talking about angle B, opposite side B is going to be lowercase b. And then C, is the angle. The opposite side is going to be lowercase c. So it's just a general way to think of these sorts of things. So let's look at two more examples, and then, or sorry, I guess there's three. Determine the length of xy. So xy is this length here. We'll call it little z because it's opposite angle big Z to the nearest tenth of a centimeter. So we're trying to find how long that side is. The only angle I know in this triangle is 70 degrees. If I go over here, this is the opposite side. This side is the hypotenuse because it's across from my 90-degree angle. It's also the longest side. And that leaves the adjacent side as 5. So if I take the tangent of theta, I'm going to take the length of the opposite side and divide it by the length of the adjacent side. So tangent of theta is length of the opposite divided by the length of the adjacent. All right, so the angle here is 70, so I'm going to take the tangent. Theta is 70 degrees. That's my angle down from this corner. The opposite side, I don't know what it is. It's z. And the adjacent side is 5. So what I'm going to do is just rearrange this. I'm going to multiply both sides by 5 to figure out what the length of z is. So now I have 5 times the tangent of 70 degrees. And remember, the tangent of 70 degrees is just a ratio. So it's just a decimal. It's just a ratio of those two sides. Is equal to z. So in my calculator, I'm going to figure out what the tangent of 5 is. And what I'm going to do is just plug the tangent in and then 5. That's it. It's going to give me a decimal. And then I'm going to take that decimal, sorry, tangent of 70 was the question. Tangent of 70. That makes more sense. I get 2.7. And I'm just going to multiply that by 5 because in this case, tangent of 70 times 5, 2.747. Maybe I can write it. 5 times 2.747 is equal to z. So all I need to do now is just multiply this by 5. So my calculator just go times 5 and I get 13.7. So 13.7 is equal to z. So there you go. Another triangle here. Determine the length of Vx, which is this side, to the nearest tenth of a centimeter. All right, so I have my longest side as my hypotenuse. The angle here, so this is my opposite side. This is my adjacent side. So we do the same thing. Tangent of my angle is equal to the opposite divided by the adjacent. What is the opposite? Well, it's 7.2. What is the angle? That's 42 degrees. So the tangent of 42 degrees is equal to opposite, 7.2, divided by the adjacent, and I don't know what that is. All right, so let's solve for it, and then we will figure out the length of that side. The adjacent's on the bottom. I'm trying to get it by itself. So what I'm going to do is I'm going to bring it to the top. So I'm going to multiply both sides by the adjacent. So I get the adjacent times the tangent of 42 degrees, which is just a ratio of sides, is equal to 7.2. The adjacent cancels. Then I'm going to divide both sides by the tangent of 42 degrees. And that's going to cancel here. What I'm going to be left with is the adjacent is equal to 7.2 divided by the tangent of 42 degrees. I'm just treating this tangent of 42 like it's a number. If I look at my calculator, if I just plug in the tangent of 42, it's going to give me the ratio of those sides, which is going to be 0.900. So this just works out to 7.2 divided by 0.900. And that just equals 8. So the length of that side is 8 centimeters. One last question. Horizontal distance of 200 meters from the base to the tower. So we know this is 200 meters. I have 8-degree angle. How high is the tower to the nearest meter? So I'm trying to figure out how high the tower is. So what I'm going to do is I'm going to take the tangent of my angle. Theta is the opposite divided by the adjacent. So over here is the opposite. This is the adjacent. This is my hypotenuse. And I don't even need my hypotenuse in this question. So take the tangent of the angle is 8 degrees. The opposite, we'll call it x. I don't know what it is. That's what I'm trying to find. And the adjacent is 200 meters in this case. Trying to get x by itself, so I'm going to multiply both sides by 200. And I end up with 200 times the tangent of 8 is equal to x. So I need to figure out what the tangent of 8 degrees is in my calculator. So I'm going to break in my calculator here. I'm going to take the tangent of 8 degrees. It's going to give me a decimal, so that's the ratio of the sides. And in this case, I'm just multiplying it by 200. So it's really easy in my calculator to go times 200 and end up with 28 meters. So the height of that tower is 28 meters. I'm going to leave it there for now. The next lesson looks at sine and cosine, which are similar functions, just dealing with different sides. So essentially everything's just the same as what we are doing. Thanks for now.